let me introduce, first of all, the two panelists I have, one from Northrop Grumman, one from Sierra Nevada. Let's see, from Northrop Grumman, Mr. Dave Hastman is the Vice President for Northrop Grumman's Innovation Systems, Human Exploration and Operations Business Area. He's responsible for business execution and performance of the CRS 1 and 2 contracts. In addition, for the Gateway Habitation and Logistics Outpost, as well as future human programs. In the past, David has served as the Vice President of Operations for the Orbital Space Systems Group, the Vice President of Launch Systems Mission Assurance, as well as served as the Pegasus Program Manager. So comes to the CRS program with a great deal of experience. We're also joined by Mr. John Curry. John is the Senior Director at Sierra Nevada and Program Director for the Dreamchaser program. He's a former NASA flight director, having led many operations for very many challenging space shuttle and space station missions, including a lot of the very much more interesting space station assembly missions. John is also a past Orion Vehicle Integration Manager and a Constellation Design Integration Manager. John also has extensive experience with the NASA and ISS international partners, having worked as an ops lead over in Russia, as well as extensive experience with the Japanese and the European partners. As Wayne mentioned earlier, Benji Reed had to go back to Hawthorne today, but he was able to provide some of the information about SpaceX's CRS efforts yesterday. Let's see, since last year's ISPCS, I thought it'd be good, as I sat here on stage last year, or stood here on stage last year, and the Soyuz 56S had just launched some 15 or so hours prior to our panel last year and suffered an abort. The crew members were fine. The crew was able to land safely. Some months later, they did relaunch the station. It's been an extremely busy 12 months. So as a matter of fact, since last year's ISPCS, standing right here, there have been 15 different vehicles launched to ISS, consisting of 6 different types of spacecraft on 4 different types of launch vehicles from 3 different countries. So in addition to all the visiting vehicles and the EVAs, robotic activities, and all the on-orbit research, we've been extremely busy. So let's see, I've got a short video that we could queue up, please. This is going to focus on the 15 different missions over the last 12 months. This is going to focus on the 6 U.S. commercial vehicles by Northrop Grumman and SpaceX, but also talk about Sierra Nevada's upcoming vehicle. The first one was the NG-10 mission. It launched shortly after we adjourned from the ISPCS last year. You can see it here in time-lapse video, sped up about 10 times, taken from the cupola window, one of the cupola windows, as it departs the ISS. A few months later was the NG-11 spacecraft. I've grouped these by spacecraft provider instead of by chronological order. You can see as NG-11 arrives here at the space station. The Canadarm reaches out to grapple it and pulls it on in. NG-11 recently completed its primary mission at ISS, but is still circling the planet more than 6 months later, or almost 6 months later now, and it's still doing secondary objectives for commercial purposes as well as for other government agencies. Then we rolled into SpaceX. We had 3 SpaceX cargo missions to the ISS over the last 12 months. You can see here as Dragon arrives at space station, is grappled, and then hovered over the berthing port on Node 2 before it's attached. The next one was SpaceX 17 here, which launched in May, arrived at the space station. Here it is in station keeping mode. The Canadarm reaches out to grapple it. This one actually contained the OCO-3, the Orbital Carbon Observatory 3, as well as a DoD payload called HTP-H6. Several months later, SpaceX 18 arrived. Notably, this Dragon contained the IDA, the second IDA, which is ISS docking adapter. This has now been installed, and this is going to enable 2 vehicles to dock to the space station. So we're very much looking forward to those U.S. commercial vehicles. This now is the Dragon 2, the first Dragon 2 vehicle. It comes in 2 variants. This is the crew variant, although uncrewed. We'll also have the cargo variant sometime next year as well. So it came up, had a perfect rendezvous and docking for the first time to the space station back in March. And you'll hear more about that during Steve Stitch's presentation here in a few moments. Let's see, also exciting news this year was Dreamchaser. We get to hear a little bit more when John comes up to speak, but really Dreamchaser is making a lot of headway in its development. This year they selected ULA as their launch provider. You can see here the Dreamchaser co-bond assembly as it's nearing completion. That's actually making its way up a highway pretty soon, and it's going to be at John's headquarters here in a matter of about a day or so. So very exciting, huge amount of progress for Dreamchaser. And we look forward to adding Dreamchaser to the fleet currently of 6 vehicles servicing space station. Dreamchaser will be there in a few years as well. On the ISS, as I mentioned, we've been very busy. So hundreds, about 300 experiments and investigations going on board space station at any particular time. That was a list of 15 different space vehicles that launched to the ISS in the last 12 months. In the last year, commercial delivery has brought 33,000 pounds of commercial resupply, spare parts, and crew consumables to the ISS. And in total, since the very first mission, which was SpaceX 1, which was 7 years ago this week, as a matter of fact, there have now been 29 missions to the ISS provided commercially, delivering over 150,000 pounds of cargo and about an equivalent amount of disposal and return. So tremendous progress just in the last 7 years. It's hard to believe we sit here just 7 years later with 29 missions under our belt. So I think that's a real credit to the folks sitting at this table and also to SpaceX. So with that, let's see, I'll hand it off to Dave.
Okay. All right. My chart's up here.
Yep, should be coming up.
There. Just stay right here.
There you go.
Okay. So right now we're in the middle of preparing for our first CRS-2 mission in early November. It's our 12th mission for CRS. And I wanted to highlight a few things in these charts that are some of the new services that we're providing that I thought was beneficial to the payload and science community. The first chart here illustrates our new pre-launch science facilities. When we set out to do CRS-2, we wanted the ISS user to have the same experience at Wallops that they have at KSC. At KSC, there's a lot of lab facilities, and so we ended up adding about 14 labs in and around Wallops for the science community to use in preparation of their payloads for the launch. Including in that is a teaming agreement that we have with Eastern Virginia Medical School. They're going to be supporting our life sciences and medical sciences. They're fairly close to the facility. And as you know, we did fly rodents on our last mission on NG-11. However, we actually imported them from KSC. On this next mission, we'll be using the EVMS facilities and flying local rodents. In addition, EVMS just actually installed and certified 2 ISS simulators, and they also have network connectivity to the NASA centers. So as a user, you can actually monitor some of your ground samples, experiments, and correlate them with the flight experiments just from your NASA facility. In addition, we have on-site support to help you with lab equipment. We also transport all of the payloads to the launch facilities for you in environmental controlled conditions to get you to the launch pad. The next chart highlights, our late load capability for time-sensitive payloads. Starting on our last mission, we rolled out what we call our late load, which is loading cargo at L-24 hours. We now have the ability to load about 20% of our cargo within 24 hours of launch, which includes up to 6 powered mid-deck lockers. On the bottom left, you can see the Antares vehicle there in the horizontal position, and it's actually been vertical and checked out with the pad. It comes back down, and in the far left of that rocket there, you can see a square building. That's our portable clean room. And that actually comes and mates up to and encloses the front end of the fairing there. And in the top right picture, you can see the pop top of the Antares fairing off. And you can actually see individuals there inside the rocket there in the fairing where we actually install a lot of the late load cargo, including the mid-deck lockers. The bottom left actually shows that where we hang the pop-top fairing there, and they're getting ready to close that out. And after we close that fairing out, we launch about approximately 18 hours after launch. Now, your cargo will get there within 96 hours from when you hand it over to us, and typically about 48 hours from launch. Next chart, please. If your science experiment is not in the form of cargo that you want to fly inside the PCM and it's in the form of a CubeSat, we have two options for CubeSat deployers on Cygnus. The first is where you would deliver your CubeSat to the launch site and it would actually fly up on the Cygnus. And then after we do our primary mission with the station, shortly after we depart, we actually do the deployments. The second option is you can actually get your CubeSat to the space station through other vehicle means, and then after we complete our mission, the crew actually does an installation, and you can see it in the bottom right corner there of a NanoRack deployer that's actually it's a CF's deployer that gets installed prior to us leaving the station. And then once again, shortly after we leave, we deploy the CubeSats. The upper right picture is actually from one of our video cameras. On the right, you can actually see the CubeSat deployer coming out, and on the left, you can just see the door popping there on that left side. Next chart, please. The last chart here that I want to go through is a new feature that we're actually demonstrating right now on our mission that's flying right now, NG-11, that Ven talked about. This is one that's been up there for a while, and we actually installed a control moment gyro on this particular vehicle. And what that allows us to do is after we leave the station, it allows us to stay on orbit and actually perform pointing maneuvers and stay on orbit for a long period of time with minimal fuel usage. Now, this is beneficial to hosted payloads that actually want to stay on Cygnus for long periods of time. And when I say hosted payloads, I'm talking about payloads where we provide certain amount of power, health keeping, thermal control for those payloads. And so if you're looking to stay up there, we think we'll have this one up there through the December timeframe, but we're looking at periods of time that we could be up there for as long as a year, demonstrating whatever the payload needs. And so we're just taking advantage of going all the way to the station, and we don't want to come down right away. We want to stay up in orbit and offer some more science capability. So. In addition, along with that, we also have a control room that provides all those operations for those secondary payloads in Virginia and in Houston, and so payloads can support from either location. So that's all I had on some of the new services.
Very good, thanks, Dave. John.
All right, thank you. I guess while they're pulling up the charts, first of all, I'm very glad for the opportunity to be here in New Mexico since I came from here. So I was born in Las Vegas, New Mexico, not Nevada. So not a gambling guy, but grew up in Albuquerque, New Mexico. Love the weather. Isn't this great weather that we're all getting to see? Next chart, please. So this one is just kind of a status on where we are. Vin highlighted some of the things, and for one of the things for you guys to know, and for our CRS-2, and Dave just summarized, we're Cygnus had transitioned from CRS-1 to CRS-2, and they're getting ready to do their first CRS-2 mission. Our first CRS-2 mission is taking a little longer because we're starting from the build phase of the first vehicle. So the picture you see there in the upper left is actually tail number one, what we call Dreamchaser number one, flight article, orbital flight article that's actually just left the building in Plant 4 at the Lockheed Martin facility in Fort Worth, Texas. And so that thing is all one big piece that's been bonded together in the autoclave. We had 5 different autoclave sessions, so we called cabin Cobon 1, cabin Cobon 2, cabin 3, body 1, body 2. That fused all that together and cured it into one big piece. So there's no rivets, there's no bolts, there's no anything in there. That's all one bonded structure, very state-of-the-art, very proud of that thing. And there in the picture on the right was taken yesterday, and the black tarp may or may not be the Batmobile that is on its way to Louisville, Colorado. And so it's been mentioned. It's expected to arrive at our facility in Louisville, Colorado tomorrow, assuming that the snowstorm doesn't do anything to how fast they get there. So as soon as we get done with this this session, I'm going to head back to Colorado because that's my baby, and I want to make sure that it does well. So that's tail number one. For you guys to know, there's also a cargo module, and I don't know if you can see it on that graphic that's on the right-hand side that just sort of shows other modules. I didn't create that picture, but it shows you where Dreamchaser would go. That's showing it on Node 2 Nadir. And there's a cargo module that's about 15 feet long that actually is where you actually berth to the space station at Node 2 Nadir. And you can split the cargo. We can actually carry pressurized cargo, unpressurized cargo to the space station, 5,500 kilograms worth of stuff that you can split the difference between pressurized and unpressurized. The cargo module can carry pressurized or unpressurized. Dreamchaser carries only pressurized because obviously all the stuff in the interstitial is being done to fly the ship and get it back home. Dreamchaser itself is capable of, it's a reusable vehicle, so it's like the space shuttle, and I don't know if any of you know that Discovery, the space shuttle Discovery, actually flew 39 times, so that's the record to me. And so when we set up the requirements, which was not imposed by Vin's team, we actually self-imposed this. We made it such that the vehicle needs to be able to fly 15 orbital missions before you actually would have to maybe see if we can recert it, extend it, or make another one and go from there. So it's a minimum 15 orbital flight life that we're shooting for on the requirement space for it. And so the first flight is in the fourth quarter of 2021. September 1st is what I'm looking for right now. If that drifts a little bit, be okay. But I want to get it into 2021. That's a big, big deal. Landing, and it's a good thing to talk about here, and I mentioned one of the reasons I was here, Christopher Allison and I got a chance to go see Spaceport America out there where the Virgin guys are going to be doing good work in here, and that is a perfect place for Dreamchaser to fly eventually. But for the CRS-2 services, we are specifically going to the shuttle landing facility at the Kennedy Space Center so that we can actually meet all the science requirements. And because we're very much focused on meeting the science requirements that came out of the CRS-2 requirement set for us to go, and that infrastructure. So if you're launching mice and loading them on the launch pad, you want to make sure that you minimize the amount of time that they're not in the hands of the experimenter. So we get it up to the space station as fast as possible. Dave mentioned the 96-hour requirement. We have the exact same requirement. We make sure that we meet that requirement, gets in the hands of the crew by that time, and then makes it back to the SLS once you've done our mission, which can be up to 80 days or so attached to the space station. And then we'll land at the Kennedy Space Center, and then you can immediately go up to the vehicle, open up the aft hatch, grab the mice, and get them in the hands of the customer. So that's a big focus for us, is to land at the SLF. But in the future, we may land at other places. But right now at the SLF. So I already mentioned that the primary structure is going to be here tomorrow, and that is on plan. Like I said, unless the weather diverts it, it's already in Colorado, so I'm hoping to see it there. Vin mentioned we did select ULA as our launch vehicle provider. We already were planning initially to go with them, but we had the Atlas V. And the way the industry is, the prices are changing, and so we spent a lot of time making sure how we could execute a 6-flight manifest and provide all of our service for CRS-2, including mission assurance if you had an issue or a problem. And so we're planning our prime rocket that we're going to plan all 6 flights on is Vulcan, but we always have the fallback that we can go to because we've already done all the work, all the non-recurring engineering for the Atlas V. So we can actually fall back to the Atlas V if something goes wrong with Vulcan. But we're all in on the Vulcan rocket. We really like that opportunity. And then we've got 6 flights, minimum 6 that we're given for the CRS-2 contract. So right now, SNC 2 through 6 will all occur between now and the end of 2024. Working those dates out with Vin and his team, but the 6th flight will be done by the end of 2024. Next chart, please. A couple other things that we have done. We actually have done a lot of work with our NASA customer to make sure that we've got a control center, and of course I'm an old control center guy. I'm very fond of this. Spent so much time in the Houston Mission Control Center. So the one that's in Louisville, Colorado is going to be our prime Mission Control Center. So our flight director that's going to be doing the execution, and his team or her team will be executing out of Louisville. So once the launch call is made by the ASOC guys for the Atlas, or in this case the Vulcan control room, and it's lifted off the pad, then the control of Dreamchaser, once in flight, will be from that room in Colorado. That's the upper left picture that you see is from that control room. Then on the right-hand side, we are actually using the Space Station Processing Facility at Kennedy Space Center to process our vehicles, because we're doing ground turnaround just like the Space Shuttle, and only our vehicle's a little smaller, so we don't have to use up a full-up OPF. We're using the SSPF, where you'd roll back off the SLF runway, go into the high bay on the manufacturing floor, in the SSPF and then roll back out to LC-41 via the ULA guys and get launched again. Control room 9 is on the second floor above in the SSPF, and so that is our backup control center and also the one that we do for all testing as we go through the acceptance testing, the final testing before pre-launch work. Next chart. So this one I want to show you, Vin showed you pictures of the space plane, and everybody likes the space plane. I do definitely too, but I also wanted to highlight the fact that we're building the cargo module at Applied Composites. It's sort of a hybrid composite. Of course, this one has to get thrown away each time because this one's performing the dispose function for us. Because part of the CRS-2 requirements is an ability to be able to dispose as well as to return cargo. So we return cargo via the space plane, and on that vehicle, on the cargo module, we can carry supplies up to the space station and then drop them off with the crew, and then the crew can then put disposal items inside the pressure vessel as much as they want. And then on the outside of that cargo module, if you see the shell of it there on the upper left picture, there will be 3 slots where you can put unpressurized cargo, whether it's science payloads, deployers, ORUs that, something might have broken on the outside of the space station, or things that we want to put on GMEF or other places would go on the outside of the cargo module and then tucked underneath the fairing and launched. So just wanted to highlight that as well. And I believe that was my last chart. Was there another chart? I think that was it.
All right.
Yeah.
Thank you, John.
You bet.
Let's see, so I'll open it up with a couple of questions.
Okay.
Let's see, with ISS, we're in our utilization phase. We're now approaching 3,000 investigations, either complete or in progress on the International Space Station. They sort of cover the whole gamut of different scientific disciplines. Transportation, of course, to and from the space station is one of the critical components of that. So I wanted to ask both of you, what have you done to maximize payload accommodations in order for the nation and NASA to maximize our investment in the space station?
Okay, I'll start first then. So, starting with CRS-2, one of the things we've added is command and telemetry capability to the payloads during transportation to the ISS. Before, they were we would fly their payloads and they wouldn't actually have any real-time telemetry or be able to command their payloads. Now, once it's installed in Cygnus, they can see the telemetry and they can actually command it. We've got what we consider a pretty soft ride for the payloads that we've verified. The other thing we've done is we've added a loop heat pipe system because on CRS-2 we actually have to accommodate 450 watts of dissipated power by the payloads, and those loop heat pipes allow us to dissipate that heat and maintain those temperatures within the proper limits.
All right, thank you.
And everything, it's kind of funny since we're both doing this CRS-2 stuff, everything Dave just said we have to accommodate as well. So the 6-powered payloads, the 450-watt heat load, all that stuff that goes in there, the metabolic load associated with mice, we are accommodating all of that. But in terms of just focus on big picture science in general, I mentioned that we can carry up 5,500 kilograms worth of stuff to the space station, both inside the pressure vessel in an air environment like this room that we've got here, as well as on the outside of the vehicle. And so that's a split that can be as much as 1,500 kilograms on the outside. If you do 1,500 on the outside, 4,000 on the inside, or if you do 5,000 on the inside, you do 500 on the outside. So it's a split. It just has to add up to 5,500 kilograms, so 12,100 pounds. That's a lot of mass. We're very proud of that capability. So that's to get it up. And then to get it down, as I mentioned, the space plane brings back up to 1,850 kilograms worth of stuff right to the runway, right where you left off. And I think that's a big deal. And then, of course, the disposal capability where we can actually dispose of both unpressurized cargo or pressurized, basically the trash, because you're actually disposing on purpose. And there's a lot of, it's a 5-bedroom house that you got up there, 1 million pounds of space, and they have a lot of stuff on space station that needs to be taken care of, and we're going to hope to provide that service as well, very much so. In terms of focusing on the science in particular, it's been on the time domain. We've spent a lot of energy on making sure that we meet these shortened timelines. Dave mentioned about the inside of 24 hours, being able to do the late load cargo. That's a big deal for us to be able to do that. Also, if you have a scrub, because the weather's bad, being able to remove all of that stuff, put it all back in, and relaunch again 24 hours later is a capability that we've been focusing on very, very carefully. And actually now with this new rocket that we've got, we were close before we were doing most of it. It looks like now I can meet all of the requirements where I can take a full amount of the time-critical cargo and turn them over if our customer wanted us to do that. And that's a big deal for science in theory. Then when we get to the space station, because the space station is very much full of business, we can operate as a laboratory while we're mated. So we don't have to take those 6-powered payloads and transfer them over to the space station. You can actually keep them inside Dreamchaser. You can actually send the commands, like Dave said, to the vehicles, either the external cargo or the inside. And so I think that's a good capability for scientists, being able to talk to their payloads throughout that 80-day mission that we were talking about while they're on the space station. And then, of course, the final one is once we land, especially the return capability. There's not a lot of return capability, especially to a runway where you can have immediate access to the science. So we actually changed our design where we have the 6-powered payloads. When you're on the launch pad, you have to go in through the dorsal hatch and load those up. Well, on the landing, if I had left those the way they are, then you have to pull a bunch of bags out of the horizontal side of the aft hatch when you're on the ground to get to those. Well, we went ahead and moved them and changed the design so that when you, right prior to unberth, you would put the mice right at the aft hatch, so that as soon as you open the aft hatch, you just grab them. Very much shortened the timeline for how long it is before it gets into the hands of the scientist. I think those are some of the ones. The 96-hour requirement, I'll just mention one last one, as we've been working with ULA as a rocket provider so I can launch into different orbits that helps with the phase angle such that we can actually have almost any day capability to launch and meet the 96-hour requirement is a big area of emphasis for us too.
Yeah, it's tremendous. You know, we took so many lessons learned from CRS-1 and fed those into CRS-2, and then both companies, all three companies really, have just even gone beyond what the original requirements were. So when I look back at CRS-1, we were trying to determine, well, what can industry do, really on a firm fixed price basis, on a set schedule with brand new spacecraft, brand new rockets. And when I look even at Orb-1, which, you know, it's the shortened cylinder, it's a 2-barrel cylinder, a couple of powered mid-decks, yeah, I mean, limited power, limited thermal, and I look at that evolution over the last half decade, and it's been tremendous.
Yeah, it has.
Okay, thank you guys. Let's see, looking forward now to either other commercial LEO applications or cislunar, what CRS-based hardware or lessons learned can you leverage to go and do other projects?
Let me go first on this one.
Sure, go ahead.
Okay, so I'm going to start by saying I've been spending all of my energy on CRS-2, but obviously I know enough to be dangerous for what our company's doing on other areas in a good way. And so some of the things that we've been bidding for the Lunar Gateway and all the work that's been going for cislunar space, there's been, and LEO, has been a significant emphasis on leveraging the NRE and the work that we've already done for the CRS-2 contract. So our cargo module that I mentioned, in the future, we dispose of the cargo module to take out the trash for our CRS-2 capability, but for future missions, you don't have to throw that stuff away. You can actually take the cargo module and then keep it in space and put some flight computer in it and give it some brains and actually have it do many jobs. And so it's a core tenet of what we're doing for the GLS type of capability, as well as our habitations type stuff, starts with that core element and the structural, so I don't have to redesign it. We'd just be leveraging that experience. The flight software, the rendezvous prox operations type of capability that we got in terms of the sensors and the technology that go with that, the EPS subsystem, the electromechanical actuators, those kind of things are all leveraged from the work that we've done on CRS-2 for all the exploration work that we're doing in the future. And these things apply, and you mentioned Lunar Gateway, but just to, and for the human element, but we also, for our satellite work that our satellite group does, a lot of this capability is being leveraged for that stuff going forward as well.
Yeah, and like John, we're doing the same thing, leveraging, you know, a lot of the NRE we did on CRS. You know, our vehicle is going to be, you know, when we talk about cislunar, it's going to be a little bit larger on the service module to accommodate significantly more propellant, so we can get there in a relatively quick time. One of the other things we're looking at too is that, you know, right now on CRS, it's more of a, you know, a closet isn't the right word, but we put the cargo in, then there's not a lot of space for the crew to operate. And so we're factoring that into our design so it can be multi-purpose, like John was talking about, to where, you know, it can handle this cargo, and there's also additional space in there if you want it to be used as a laboratory or an extension to the habitat volume. And so that's the other thing we're looking at. You know, pretty much all the sensors and the software on rendezvous and prox ops, all that's going to be very similar. We won't be berthing, we'll be docking, so we'll be modifying our vehicle to include a docking system because it'll all be autonomous. And then we're also trying to think about, what we've learned over the last multiple years in terms of how ISS has changed. And since Gateway is going to be up there for 15 years, how is that going to change? So right now, we think we know what Gateway wants, and you could argue some people, well, not sure about that, but how that's going to evolve, and we're trying to figure out, what the potential needs are. And, part of that is, NASA wants to go to time trigger Ethernet, so some of our systems will be able to support time trigger Ethernet for the payloads. So.
Okay, let's see. Continuing along the theme of use of CRS models elsewhere, how about the procurement model? Does it translate well, and does the public-private partnership means that we've developed over the last 10 years, how does that translate for future programs, or should there be changes?
Yeah, so I'll go first on this one. So on CRS, I think it worked out really well with the COPS development and then moving on to CRS, and the fact that there was a guaranteed certain number of missions. Moving forward, it definitely looks like NASA is moving away from that same kind of guaranteed work. We've struggled a little bit on CRS to supplement CRS with commercial users, and with the hope of that would blossom into additional revenue streams. And so there is a concern that how the lunar model works if there's not going to be a certain amount of guaranteed government work, and how much of that has to be supplemented to make up for our investment on the commercial side.
Okay. Yeah, I agree with a lot of what Dave just said. Having started Dreamchaser for 10 years ago, when I first came over, all we had was a $20 million contract called CCDEV1, and then it leveraged to CCDEV2, and then CCI cap, and then CCT cap, and then this commercial, and leveraged into the design that we had. So we were able to take the crew design and work on our way into the CRS2 design, and it was critical that you gave us the minimum 6 for sure, to be able to help with that. It was very useful in terms of the financials to make sure that you can actually go through that tough period that I'm going through right now, where I'm not able to make money because I haven't actually flown yet. And so that gives you that opportunity to do that. I think moving forward, that's like Dave said, it's looking like it's tougher now, where the risk seems to be leveraged more on the commercial provider side and less on the NASA side. Because of the market. There is, what market are you trying to leverage? And so you're asking companies to take a lot of risk, I think. And so the risk is high and the reward is unknown because the market's not there. And so I think NASA's probably going to need to think about that, about whether they can do something that's a little more of a shared risk of what we're talking about moving forward. You're going to lose the littler guys, for sure. I think that's the only thing. The CRS2 model worked because we were able to take little pieces and work our way forward, and then the minimum 6 was a big deal. But that's not the way the contracts are looking right now. From where he is, it looks like the risk's mostly on the commercial provider side, and the word partnership is not looking like it's really measuring that way. I guess if there was any feedback I was going to give on that.
Okay, all right, we'll factor that in. Let's see, I'll ask one more, and then perhaps we'll take some from the audience. Let's see. How would researchers or payload developers work with your respective companies in order to fly on your vehicles?
So there's several different avenues, but we have some folks that are dedicated to supporting the secondary missions. So anybody interested, we can hook you up with points of contact there. Some advice, depending on the how complicated your payload is, the sooner you contact us, the better. Clearly we have standard interfaces that if you comply with, you can come in pretty late in the game and we can accommodate you no problem. But as you get more sophisticated and have things that are outside the standard, we like a little bit of time to modify our vehicles, because we do try to build our vehicles a little bit ahead of schedule. The other thing we like to do on the more complex payloads too is we like to make sure that we do a ground test with your payload. And we verify all the interfaces with one of our flight vehicles at the Dulles facility before you show up to the launch site. That's typically worked well for ensuring that both sides are prepared and the payload makes the launch. So reach out to us, get a hold of us, and start talking to us early, even if it's notional, because we can give you a lot of good information on what to think about.
All right.
Yeah, and for us, because our vehicle is very capable, where we can do the up and the down and the disposal versus return, pressurized, unpressurized capability. A key thing we've been working with your team, Vin, and has been very helpful is developing basically kind of a user's guide or a capabilities set of documents. So for somebody who wants to come in and fly on our vehicle says, well, what's your capability? If I want to fly this payload, is it going to fit? Is it the right size mass? Dave mentioned about, hey, we'd like you to come in by X amount of time, because it does take a while on long leads if you're doing something very complicated. And you guys have been helping us with that very much, is to document what we're doing. In terms of high level, for anybody who doesn't know on the way the CRS-2 contract goes, most of the payloads that fly on our vehicle are going to come through the CRS-2 program through cases, I believe, and it comes through that path. And so we just get asked to fly that stuff on your behalf, and we do that. But the unutilized capacity is an opportunity that we could do, because we do have volume that's not taken up necessarily, conformal volume or sand volume that's in the edges that in theory you could fly stuff on the pressurized cargo area, assuming we're not doing anything of the detriment to the NASA customer. And then the uncrusted cargo slots, if you guys didn't use one, we have discussed there's a possibility that we could actually let somebody else fly with that as a direct customer. And Christopher Allison, who's in the crowd here, and he spoke earlier on the FAA, he doesn't just do FAA for us. He's actually our point man for payloads that want to fly. So if anybody was interested in flying on Dreamchaser, go see that gentleman, and then he's going to make it happen, right, Christopher? No pressure.
Okay, thank you.
So, Vin, I'm going to start first with a little public service announcement. I know we have a number of students in the audience, and we speak acronym up here. And for those of you that didn't understand some of the answers to some of the questions, let me provide a little decoding for you. NRE, non-recurring engineering. That's the engineering you have to do to develop a new system. So if you talk about, saving NRE, you're trying to save the money for the engineering. Space Station Processing Facility, SSPF, is a facility, a building at the Kennedy Space Center where they can do things like check out spacecraft. LC-41, Launch Complex 41, where the Atlas launches from. Mars, Mid-Atlantic Regional Spaceport, otherwise known as Wallops Island, actually in the state of Virginia. And I'll think of some others, but we have had a little bit of acronym salad here. So start out with that. And now I'm going to start with the question that, as the shuttle program manager, was my second least favorite question. What is the upmast cost, dollars per kilogram, for each option, for each provider?
It's probably actually company proprietary information, I think.
Yes, it is.
For you guys. I will say it's coming down, so the trend is correct, but I think as far as the particulars, that's proprietary to each company.
Okay. So everybody gets to do your own math on
Right.
upmast,
Do your own
downmast cost, because we're not going to tell you here.
Yeah.
As more companies want to access the ISS more frequently, will there be a problem with competition for the docking locations?
Yeah, I'd be happy to help field that one. So our current configuration now, as soon as SpaceX 18 dropped off the second ISS docking adapter, we now have 2 docking ports and 2 berthing ports on the U.S. side of the space station. The Russians also have 4 docking ports that they use for the Soyuz in progress. Going forward, when we look at the mix of vehicles, both the Boeing CST-100 as well as both the Dragon 2, which consists of both the cargo and the crew variations of Dragon, will use the docking ports. And Cygnus will continue to use the berthing port, and there's an option to use Sierra Nevada for either docking or berthing. Currently, SNC-1, the early SNC-1s will be for berthing. So it's going to be busy. As I mentioned at the beginning, we have 14 or 15 vehicles come into station every year. So it's a little bit like Grand Central Station. As a matter of fact, with the HTV, which I forgot to mention a moment ago, delay for HTV-8, which just occurred, we ended up having to delay the NG-12 launch by a few weeks in order to free up berthing and docking, berthing ports.
Good.
Now, one thing I will add, and this is something that ties to our CMG, one of the reasons we started the experiment with the CMGs was the thought process that we would go to station and either deliver some payloads or some payloads would come on. We would depart, save fuel, and actually return to the station. So that's still out there that we've thought about as an option, but we have not pursued it yet with NASA.
And again, for the students, CMGs, control them, gyros, allow you to do attitude control without using
This will be a
rockets.
test for me to see if I can do it with it.
Okay, it's a tough crowd. Are there any specific payloads prioritized, or are all payloads of the same cost equal? How do you prioritize payloads?
We do actually, the utilization on board space station, the USOS, the non-Russian parts of it are actually prioritized by our NASA, primarily exploration folks, as well as by CASIS, and CASIS and NASA split about 50-50, exactly 50-50, the resources on board station. That can include crew time, power, volume, up mass, you name it. And so the prioritization actually occurs based on some set boards and panels, which prioritize based on scientific return and time frame and so forth. So for the exploration side, we're trying to complete as much as we can the exploration research, which is going to feed into long duration missions to the moon and to Mars.
Very good. This is, pardon me, this is a tough crowd here, and the newest question that just zinged right to the top with the most votes is, why are you so opaque about what it costs to use your services? Isn't the point of us being here to help lower the barrier to entry to space? Why are we being so opaque about cost?
I think it's competition sensitive between the vendors.
Yeah, if we have a non-disclosure agreement and we're working through something, we can actually negotiate all that stuff with you, no problem at all. That's what it comes down to. It just doesn't go out on open source.
Right, and if it comes in, and our deputy program scientist can help answer as well, but if it comes in through CASIS or through NASA's sponsored experiments, NASA actually subsidizes that cost.
See, I'm so glad that I'm not in the government anymore, so I can actually answer questions. Right. Okay, moving on to a different topic. What major changes would there be to your vehicles to adapt for gateway logistics services?
So it's probably going to be the propulsion system. We're going to need to double the size of that. Not that that's technically challenging, but it does push us to a bigger volume, and we'll go on to a bigger launch vehicle. And as mentioned before, we will be doing some C&DH architecture changes to accommodate the time-triggered Ethernet. But as far as the sensors and the rest of the services, they're going to be very similar.
I think the answer for mine is that because we have two different spacecraft, we've got the space plane and then you've got the cargo module, which in this case for the gateway logistics services would again just be something that stays in space permanently. So a winged vehicle probably doesn't make sense to spend it all the way out to the lunar gateway and back, because the wings are performing a specific function of taking stuff up and down. So if you bring in lunar regolith black and those kind of things, the space plane would be great to bring that home and back to the runway, or to bring people or supplies to low Earth orbit and then transfer to something with solar electric propulsion or something to get you to the lunar gateway would be the way to do it with the Dreamchaser in the mix. And then I already mentioned that the cargo module is a key part of what we've got for the habitation services or the GLS, the gateway logistics service, excuse me, Wayne. That we could utilize and have and intend to utilize for the exploration program.
Very good. How are you preparing for NASA's planned shift to industrialized, or I would say commercialized ISS, where you may go from a single resupply customer, which is NASA, to multiple commercial customers?
We're actively engaged with many of the other customers who are actually talking about there's a port utilization study and work going on there about that, and we've got a lot of interest in what's going on there. Obviously, for Dreamchaser, because of our return capability, and I know there was folks presented earlier about materials and certain things that can be made in space and then need to be returned back home. So that's a very good commercial capability that I think I can provide a service for to get this stuff back to a gentle runway landing for sure. There's a bunch of others that are also talking about independent capabilities in low Earth orbit for commercialization, other hotels in space or other service providers that are doing long duration science. And actually Dreamchaser itself, we, just like David mentioned about his vehicle, we fully intend to start leveraging the Dreamchaser capability to be way more than 80 days. We originally designed for 210, and so you're getting it with the solar array capability and others, you can go into 1 year type missions where we can perform science as an independent science capability. We can do Hubble Space Telescope repair. something like that. Somebody wants to bring it up to me, we'll be more than happy to accommodate.
And, likewise, there's two parts for us. We believe that, we could offer, in addition to cargo and the similar services you get now, we could also offer habitat space and things like that with some of the modules we build. And then, from a NASA perspective, if we can offset the NASA cost by offering up delivery of cargo for commercial folks, then we can discount the prices to NASA.
Good. There's a couple of these I'm going to quickly answer because I know they're a little, what's the difference between a berthing port and a docking port? There are two different mechanisms with two different hatch sizes. Berthing, of course, is accomplished by grabbing the vehicle with the robot arming and pulling it down to a berthing port. Docking is where the vehicle flies directly in, and it's got a different mechanism to latch into that. So that's the difference for those of you that don't know. The next question is, how do you dispose of the trash without adding to space debris? Very simply, they perform a deorbit burn, and that trash is then, very immediately burned up in the atmosphere on the way home. Next most popular question is, how far are the CRS-2 vehicles from being able to handle crew? And Derek, I would say probably not very close for you to handle crew, Dave to handle crew.
Right.
But John may want to take that one.
Yeah, so we still have a SpaceX agreement. The CCI-CAP, as many of you may know, we came pretty close to winning the commercial crew program. We came in third, but not because our design was poor, and we came back in and we won the CRS-2 program. And I've always appreciated Bill Gerstmeyer for giving me the opportunity to do this under CRS-2, because I still think this is a wonderful people mover, and it's going to change the world once we get an opportunity. So we've continued our funded CCI-CAP. Our last objective was met when we did the approach and landing test at Edwards Air Force Base to show that regardless of whether you're crewed or uncrewed capability, that you can actually, the physics of how you do that and coming back from space and landing are the same. So that part of it is good. The changes that you have to make to Dreamchaser is you'd have to we took out the abort system because we added the payload mass to meet the CRS-2 requirements. So you'd have to put the abort system back in, which we had gotten to a certain level of maturity when we lost crew. And so you put a couple of abort nozzles on the back. In this case, you would be changing the design because we don't want to go backwards. We like the CRS-2 design. The cargo module would probably become some kind of abort system rather than being a cargo module where it would hold additional fuel for the abort system capability, give you additional delta V for what you want to do, and then the abort nozzles to escape from the rocket if you had the problem. One thing, the difference between CRS-2 and the crew is we were unfared for crew, because if you did have a bad day, picture Challenger type of bad day, but you could get away, then you could re-land, do a return to launch site abort and end up on the runway. So we'd want to actually probably go unfared. So you'd go with a partially fared capability off of what we're doing with a fixed wing. On CRS-2, we have the wings folded in under the fairing, gives us a nice quiet ride, but it's got limits when you're talking about aborts. So if you're going up an East Coast abort, that would be the kind of thing you'd probably go unfared and change that design back to a fixed wing. And then the other things is probably more straightforward, putting the seats back in. And then the cool thing is, since we're actually designing this whole thing to do it automated, where I don't have to have a human in the loop, any of the augmentation for the human capability would be an add-on to what we've already got as a capability. One thing that might not be intuitively obvious to you either, and I've got 3 astronauts on my team, and they're okay with this, so I'm going to tell you this up front, is we don't have windows on our CRS-2 version. We took them away. The mice don't get to vote, so they're not looking out the windows. But if we go forward, we won't put the windows back in because it's 500-pound hit on mass. The outer mold lines is more complicated. And we'll go with an enhanced vision system that's built by our company. We've already looked at it, that would actually allow us to use that same capability, and then you'd be just looking through the vehicle with cameras and other optical instruments and land that way. So I think that's the answer.
We're out of time, but the bonus question, which I'm going to let Ben answer, is how many flights are both the providers on contract for? How many flights?
Let's see, all 3 CRS-2 vendors get 6 flight minimum. So we've purchased 6. We're going to purchase 6, and we'll decide where to place them. After that, it's competitive. It's competitive for each additional one after that. Also, back on your last question, just real quickly, the SpaceX guys would probably answer that is the Dragon 2. It's going to have the 2 variants, right? It's going to be cargo and crew. So their outer mold line is the same. There's a lot of commonality for the outside as well as for the infrastructure. The internals are different because one will have to support crew members with life support and so forth. The other one will maximize the amount of cargo. So it's not quite like having a General Motors and a Chevy coming off the same assembly line, but they do sort of start very similar, and they leverage off each other.
Good. Well, thank you very much. Let's give the panel a round of applause for the talk.